is the integumentary system. Integumentary is just a fancy word for skin. The integumentary system is your skin system. Okay? So, your skin is your largest organ. Okay? It accounts for about 7% of your body's weight, which is a pretty significant amount. It varies in thickness depending on where you are in the body, anywhere from 1.5 millimeters to 4.4. Okay? And the skin is divided into two distinct layers. The first is the epidermis. We've talked about that a lot. The epidermis is made out of what type of cell? What type of tissue? And yes, epithelium. Okay. And then the second division is the dermis. Dermis is just below the epidermis. Makes sense, right? Because that root epi means on top of or upon. So the epidermis is right on top of the dermis. There's one more layer, not technically a part of the skin, but we talk about it as such, is the hypodermis. Where do you think that one's going to be? It's going to be under the skin. That root hypo means below or under, okay? Hypodermis is going to be under the dermis. And the hypodermis is made up of areolar and adipose tissue. What kind of tissue is that areolar or adipose? If you were in lab today, you have an answer. Adipose is fat, yes, but what type of tissue? Adipose is a type of tissue. We have 4 types of tissues. I'm looking for a specific, not even really a specific type of tissue. One of the 4 types of tissue. Connective. Yeah, adipose and areolar are both connective tissues. Okay. So the hypodermis is technically not part of the integumentary system, but it does share some of the properties that skin has. So we like to include it in the conversation. Okay? Cool? Cool. So this is a model of the structure of skin. Okay? So all of this part right here is the epidermis. That's just the first 5 layers, 4 to 5 of your skin. Underneath that is the dermis. That's all of this stuff in pink. And so you can see that most of the stuff that's going on in the skin is actually happening in the dermis, right? The dermis is where the blood flow is. It's where most of the extra cells, appendages, anything like that, any glands, they all sit in that dermal layer, okay? This is it again, but more specifically on a modeled human. So this is the epidermis, that's first layer. Below that is the dermis, then the hypodermis. Then you have deep fascia. Fascia is just connective tissue. And then below that is the muscle. Okay. There's a lot going on under the first few layers of your skin. Okay. So what does the skin do? What functions does it do? Okay. First, and probably one of the most important, is protection. It is the job of the skin to cushion all of your internal organs and protect you from any bumps, bruises, any chemicals, losing water, and any UV radiation. You get UV radiation from walking outside. The sun, point blank period. That's why we wear sunscreen. Because as much as our skin does do some protection about UV radiation, it's not perfect and it's not going to protect against everything. Okay? So that's why we wear sunscreen. All right? The second is body temperature regulation. Okay? Your skin has lots of networks of capillaries and other sweat glands that help to kind of regulate loss of heat, right? So it's super hot outside right now, and so a lot of us are sweating. In that sweating, our skin is saying, hey, too warm. Sweat glands, start letting go of some of that excess liquid. We don't really need it right now. That liquid is going to sit on our skin and evaporate and hopefully cool down the body. But if it cools down too much, then we'll get cold, and that's a different thing. Our body is always trying to maintain homeostasis. Homeostasis is just stasis, a fancy word for equilibrium. Homeostasis is your body going to its regular set point. And that set point can be a little bit different for everyone. I'm sure you've heard that the average human temperature is 98.6 or something like that. But there are some people that run a little warmer. Their set point can be like 99.1, and that's normal for them. And there are people that run a little cooler. Their set point can be anywhere from like 97.2 or something like that. So whatever that set point is can be a little bit different for each person, but it does tend to fall within a range that is normal for humans, okay? And then the third 3 of 5 thing that the skin and hypodermis does is it does quite a bit of excretion. I just talked about that. We sweat. We sweat through your skin. There's only one place that doesn't sweat, and I think it's like the back of your ears or something like that, or somewhere else silly and ridiculous, okay? Everywhere else on your body will get rid of urea, which is a nitrogenous waste, salt, and water. There is another way that we get rid of urea, and that is through urinating, okay? Going potty, okay? Next function of the skin is the production of vitamin D. Vitamin D is necessary for us to process a lot of the foods that we eat. It's also incredibly useful in regulation of some neurotransmitters. So it's super important that you go outside, go touch some grass, go allow your skin to produce that vitamin D. It will make you feel better. It will make your brain function better. There is science that goes behind that, okay? So if you're stuck in this is a small little, okay? And then the last function of the skin is sensory reception. You have all kinds of nerve endings and stuff in your skin. That's why you can feel when there's an ant on you or a fly or something teeny tiny that shouldn't bother a big old human like you, but you can feel it because of all of those nerve endings, okay? So this says sensory reception. It just does not want me to put an E there, but it exists, okay? Cool? Cool. So now that we've talked about the functions of the skin, let's talk the skin itself. The epidermis is made up of keratinized, stratified squamous epithelium. What would I expect if I were to look at these cells underneath a microscope? What would I expect to see? Would I expect to see one layer or many? Many layers of what kind of type of cell? Flat, cube, or column? Are you sure? Flat, cubed, or column? Pardon me. Flat. Pardon me, guys. Flat. Many layers of flat epithelium. They will have what we call keratin. Keratin is a what? A protein. It is a protein that helps to waterproof, harden, all kinds of stuff. Okay? There are 4 main types of cells that you will find in the epidermis, in that top layer of skin. The first is keratinocytes. Keratinocytes. Keratinocytes are literally keratin cells. They produce keratin. Keratin is a protein, a fibrous one at that. This is all information that you have already heard, okay? So keratinocytes are cell type number 1. You're going to find those in the stratum spinosum. That is one of the 5 layers of the skin. And we'll go into all of the layers as well, so don't get too scared, okay? The next type of cell that you would find in the epidermis are melanocytes. Melanocytes are the cells that secrete pigment, okay? So for all of us that are pigmented people, there's different varying levels of melanocytes in our skin. There's 3 different types of pigments. There is melanin, there is keratin, E-N. I don't know if that's spelled right. And then there's a third one that I don't remember right this moment, but it'll come up later, probably. Okay? Okay. Another type of cell that you will find in the epidermis are the tactile epithelial cells. Okay. These tactile epithelial cells attach to nerve endings, and they help you register things like pressure, vibration, things like that. And the last cell type that we would find in the epidermis are the dendritic cells. Not to be confused with dendrites of your neurons, but dendritic cells are these macrophage-like immune cells that kind of clear up any debris, anything that's kind of been broken down in that epidermal layer. Okay? Let's not do that. Removes debris. Okay? The cell type that is most abundant is going to be your keratinocytes. Your keratinocytes, they start at the deepest layer of the epidermis, and they go up, until at some point they will die because they are no longer getting blood. And towards the top of your skin, every time you slough off some skin, you are sloughing off dead keratinocytes, cells that are full of keratin but are dead. Okay? They produce keratin. They also produce some antibiotics and enzymes. That's what prevents, like, every time you get a cut, it doesn't immediately get infected. Those keratinocytes also make some mild antibiotic properties and some enzymes that kind of break stuff down so that, you know, not every single thing that touches your skin makes you ill. And they are dead at the skin's surface. Okay? Like I've been saying, there are 5 layers of the skin. Starting from the bottom, let's say that this down here is the dermis. Okay, so starting from the most basement layer, the one that is closest to the dermis, we have the stratum basale, also known as the stratum geminitivum. I will literally never call it this because I think this word is hard to say. I'm always going to say stratum basale. Okay. At this level, you have a bunch of keratinocytes, and they are at this point alive. Okay, because they are still getting blood flow from the dermis, from the vessels that are close enough to the dermis. Okay. Next up is stratum spinosum. Stratum spinosum is named because the keratinocytes make what look kind of like spines when we take these cells out and put them on a plate. It just kind of looks spiny, so they literally called it the spiny layer. Biologists are not creative. When in doubt, assume that biologists are not creative. They are going to name things based on what is simple, okay? So stratum spinosum, you still have your keratinocytes, and they are still alive, kind of. Most of them are still alive. Probably have a couple of the weak ones are dying off now, right? But most of them, majority, are still alive. Okay? Then we get into stratum granulosum. Stratum granulosum is named because the cells start to look a little granule. They look a little grainy. At this point, most of your keratinocytes are starting to die. They are starting to, if not already, dead. Okay. This fourth layer is special. We only see this layer in thick skin. And that is stratum lucidium. Okay. Stratum lucidium is named because it is clear. Lucid means clear. Lucidium is the clear layer. You only find stratum lucidium on the palms of your hands and the soles of your feet. Thick skin only. Okay. And then the top layer is stratum corneum. Okay, stratum corneum. That is a relatively thick layer, and it is full of dead keratinocytes. Okay. So, from bottom, closest to the dermis, to top, far most superficial, basale, spinosum, granulosum, special case lucidium, and corneum. Got it? Cool. There it is. This is stratum basale, first basal layer. That dermis is close by, still getting blood flow. All of these guys are still alive. Spinosum, we're starting to make our keratin. Some of our cells are starting to die off just a little bit, but it's mostly just filling up with keratin. Granulosum, we've got them. It's a really little layer, but they look kind of grainy, okay? Your organelles are starting to fall apart. Your cytoplasm is starting to go away because these cells are no longer close enough to a blood supply to be getting fresh oxygen, anything like that. So everything is starting to die off, okay? You notice there is no lucidium in this image. This must not be thick skin. So that we get our top layer, stratum corneum, 20 to 30 layers of dead cells. dead. Okay? Same thing, different way of looking at it. Now we're going to talk about all of the layers and all of the things that you're going to find in each of the layers. Okay? In stratum basale, which is the deepest layer, it is attached directly to the dermis. These cells are actively dividing. Meaning they are going through mitosis, they're going throughout the phases of mitosis, making more of themselves, all of that stuff. Okay? Stratum basale contains the tactile epithelial cells, and the melanocytes. Also some keratinocytes, but nothing too crazy. Okay. This is thick skin. You can see all all 5 of the layers. Okay, so basale sitting right through here. Spinosum, a little spiny, changes color. We get into granulosum. Stratum lucidium. It's a very thin, clear layer. You literally can't even, I've already probably drawn over it. You have to see it real up close. And then stratum corneum. 20 to 30 layers, all dead. Whatever that's squeaking is driving me insane. I think it's a bird or flag. Okay, next layer, stratum spinosum. Literally looks spiny. It is a histological artifact. When we take the cells out, we stain them, we put them on a slide, it has this spiny look to them. The cells themselves are not spiny. It's just a product of preparing the slide to be looked at. Okay. Stratum spinosum contains some thick filaments, thick bundles of intermediate filaments. Okay. Remember, intermediate filaments are part of your cytoskeleton. Right? And they resist tension and contain the pre-keratin. It's not quite keratin, but the step before it. They also have those dendritic cells that, again, help to kind of get rid of any excess debris. By excess debris. Okay. Stratum granulosum has a few layers of keratinocytes, and those after saying keratinocytes so many times, it no longer becomes a word. So here we are. Those keratinocytes have these keratohyalin granules. If you were in lab today, you heard this word when referring to cartilage, hyaline cartilage. That hyaline means glassy. Okay? So these glassy keratin granules, they help form the mature keratin. Okay? And then the stratum granulosum also has the lamellar granules, and those have the waterproofing glycolipid. So the thing that makes your skin waterproof shows up in this layer. What is a glycolipid? It is a fat sugar. It is a sugar-based fat, or a fat-based sugar. Okay. Anywhere above this stratum granulosum, these cells are too far away from the dermis to get blood flow. So they are dead, dying, or close to it, okay? Anything above granulosum, and there's only 2 layers above granulosum, 1.25 actually, but above granulosum. You with me? Cool. Stratum lucidium is our clear layer, only shows up in thick skin. And thick skin is only on the palms of your hands and the soles of your feet. And it's just a few rows of flat, all dead keratinocytes. And then the stratum corneum. It is a thick layer of dead or alive keratinocytes. Dead. They're dead. They've been dead since granulosum. That's 2 layers ago, okay? And they protect the skin against abrasion and penetration. For all of my clumsy folks, your stratum corneum is the reason that every time you bump your elbow, it doesn't just like, I'm bleeding out, right? Your stratum corneum helps to protect you against that, okay? For all of my clumsy wumsies. Okay? And that's pretty much it for the epidermis. The epidermis has those 5 layers. I'm actually going to pause right here about the dermis. The dermis is the second major region of the skin. It is quite strong and quite flexible, and it is made up mostly of connective tissue. The dermis, though, is a composite tissue, meaning that it has some epithelial properties, it has some connective properties, okay? It is richly supplied with blood vessels and nerves, so it is highly vascular and highly innervated. Okay? There are 2 main layers of the dermis, the papillary dermis, and the reticular dermis. Okay? The papillary dermis is mostly just on top. The reticular dermis is going to be the majority of your dermal tissue. Okay. So the papillary dermis has what we call dermal papillae. Those dermal papillae, they're these little like ridges, kind of like the microvilli that we saw on some of our epithelial tissue. They're these ridges, right? And those ridges will increase the surface area for gas exchange of nutrients, waters, all kinds of stuff, waste, everything. Those dermal papillae lie on what we call dermal ridges. Okay. The dermal ridges are just like kind of the hump. There's an image that will show it a little bit better. The top part of this kind of bump up here. Okay. The epidermal ridges are where we straight up just lift up the dermal ridges. Pop up here. And you'll see those as your fingerprints, okay? If you look at your hands, you'll see all these little tiny lines on your fingertips, all of that stuff. If you've ever had to get your fingerprints done for like a job or anything like that, a live scan, anything, your fingerprints are unique to you. The only time that you will have a fingerprint that is not unique is if you are an identical twin. Fraternal twins have different fingerprints. Identical twins have the exact same fingerprint. Okay? And they're used to grip stuff. When you go in water for a really long time, your fingers get all pruny. That's an evolutionary mechanism to help you grip things after being wet, right? We have that ability to grip things due to those epidermal and dermal papillae. Okay. The reticular dermis, made up mostly of dense, irregular connective tissue. For those of you who were in lab today, what kind of fiber makes up this dense, irregular? So that dense, irregular connective tissue makes up these cleavage lines, and those cleavage lines are the separations between those collagen fibers, okay? And the collagen fibers give the skin strength so that you can, you know, that's going to be flexure lines, bro. Okay. These flexure lines are made by the reticular dermis, and you'll find them in your palms, your wrist, anywhere that has a bend that as you were developing, were kind of crunched up. You'll see those those flexure lines. So like the palms of your hands, when you kind of pull your palms in, you'll see that there. When you bend your wrist in, you'll see them there. In your ankles, your fingers, your toes, all that kind of stuff. Okay. The reticular dermis, highly innervated. And has these two vascular plexuses that are vital for its vascularization, for its blood nourishment. Those are the dermal plexus and the subpapillary plexus. Papillary plexus. Okay. Your blood vessels play an important role in that temperature regulation. The more open your blood vessels are, the more blood is passing through, the hopefully cooler you will get. The more constricted your blood vessels are, the less blood passing through, you are losing less heat. Okay? So constricting your blood vessels keeps you warm. Okay. Dermal modifications. These are the cleavage lines that I was talking about. That collagen fiber in the reticular dermis that has these irregular kind of shapes. Those cleavage lines are where they separate. The flexure lines, and then the friction ridges that are on your fingertips in the epidermis. Nope, not epidermis. Dermal papillae. Okay. The hypodermis, the unofficial third layer of the skin. Hypodermis, it's going to be deep to the dermis. Obviously, hypo means below. So it's going to be below the dermis. Also called the superficial fascia, and it contains both areolar and adipose connective tissue. Okay. And the hypodermis is what anchors the skin to any of the underlying structures. So like the muscles, the bones, anything like that. It helps to insulate the body. Bro. Insulate is just a fancy word for keep warm. Helps keep you warm. And there are different distributions of this hypodermis in males and females. Females will have this distribution of hypodermis more so in like the hips, in the stomach, in the butt area, in the breasts, whereas males, you'll see more of that hypodermal distribution in like the legs, in the arms, stuff like that. Okay? almost there, guys. I'm sorry. We're doing it. Okay? Skin color, 3 different pigments. Like I said, there are 3 pigments that contribute mostly to skin color. The first is melanin. I think I might have said melatonin up at the top. That's a sleep hormone. That's not it. It's melanin. Okay? Misspeak. That was a misspeak on my part. If I did say it, if I didn't, then drop that. But melanin, super important, made from the amino acid tyrosine, and it has a brownish, reddish pigment. Brownish, reddish, blackish pigment. Okay. The second is carotene. Carotene is a yellowy orange pigment, and you find it in carrots. Biologists are not creative. Carotene has a carrot-like color. Okay? And then the third one, the one that I forgot, is hemoglobin. Hemoglobin, it's technically a pigment, but it's more so a blood protein. And if you can see like the redness, that is a lack of other pigments. Okay? So seeing hemoglobin is mostly just not seeing any other types of pigmentation. But hemoglobin technically is a pigment, and it is red like your blood. I think we save the rest of this for Thursday. Actually, okay. Nails. Nails are a part of your epidermis. They are a modification of the epidermis, and they are made of hard keratin. There are a few parts of the nail. The free edge, that's this part, the edgy part, right? The nail plate, that's the part that is actually sitting on your finger. The root, that's kind of towards the back, right, where the blood flow is. The nail folds are the guys on the sides that kind of separate your skin from your nail. The part that when you get a little like hangnail and you peel it, it'll peel all the way up your skin and it hurts and it sucks and it's the worst. That's a nail fold. And the eponchium is a cuticle, okay? Whatever that word is, that's a cuticle. Eponchium, that sounds right, is a cuticle, okay? That's what it looks like. The free edge is the part that you use the clippers on. The nail plate is actually attached to your skin. You have lateral nail folds. That's what separates your nail from your skin on either side. The eponchium, the cuticle, is at the back, okay? And then the root of the nail is just a little bit below that cuticle, and that's where the nail grows from. So you can assume that there are some blood vessels, some dermal layers just below this to get blood flow, okay? That's why when you accidentally like slam your finger into a car door, you get that like immediate bruising, that immediate like color change in your fingernails, because there are blood vessels here that are now just free because something broke in there, okay? Hair. Hair can be a little bit complicated, but it is pretty cool. It is mostly just a flexible strand of dead keratin, keratinized cells. So if you ever have a haircut that you absolutely just hate, don't be too sad. They were all dead anyway, okay? You were fine. It is hard keratin that is tough and durable, the same kind of hard keratin that makes up your nails, okay? The main parts of the hair that we care about are the root. You cannot see the roots of your hair. Well, you can, but not really. They're deeper under your skin. And the shaft. The shaft of your hair is what you see, okay? Hair has 3 layers. 3. The center is the medulla. Makes sense. Medulla is in the middle. Medulla, middle medulla, right? Just outside the medulla is the cortex. Okay? Cortex, same thing like a brain cortex, but you don't know that yet, so let me drop that. And then outside of the cortex is the cuticle. Your hair also has a cuticle, and that cuticle layer mostly just is for like protection, retaining moisture. Usually when you have split ends, it's that your cuticle layer has kind of just started to fray. It is not as healthy as it once used to be. I'm not judging your journey. Don't look at your split ends and look at me. I didn't do that. All right. Yeah? Cool. There it is. The medulla, the cortex, medulla, the cortex, and then the cuticle just outside. Okay? There are a whole bunch of sheaths kind of outside of the hair as well. You have the follicle wall. That's all of this in here. That all just has a bunch of dead cells just to give your hair some body. Body, yaddy, 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 yaddy. There it is again. Glassy membrane of the cell. Okay. Hair has some appendages. There are the hair follicles. Hair follicles extend from the epidermis into the dermis. Okay, that's kind of the, let's do this. Okay. So the follicle would be that kind of this part in here, going from the epidermis into the dermis. The wall of that follicle has the peripheral connective tissue sheath, the glassy membrane, and the epithelial root sheath. The bulb goes deep into the hair follicle, and then, deep into the dermis at the end of the follicle, and then there is a root plexus. This root plexus is kind of just, it's a bunch of nerves that sit around the hair bulb itself. Bless you. Oh, you guys are so nice. I've never had a whole class say bless you to someone. That was cute. Okay, so the root plexus is why you can feel all those teeny tiny little ants. They brush the hair, and that hair sends its little vibration all the way down to that root plexus, and your body says, hey, there's something here. I don't know what it is, but it could be crazy. Do something, okay? So that's why. That's kind of what it looks like. That hair bulb deep, deep, deep in the dermis. Okay? There it is again. So all of this is the medulla. Okay? Just outside of that is the cortex. Let's maybe do that in a different color. Let's try blue. Cortex. And then the outermost layer, the cuticle. The hair matrix right above that dermal papillae is going to be where you get the most division of cells. Okay? The erector pili muscle. Erector pili muscles is just a bundle of smooth muscle, and it is what gives you goosebumps, right? So whenever you are cold, it is an involuntary muscle contraction. When you are cold, that erector pili muscle contracts and tries to, and it ends up pulling on the hairs, but that's just an effect of those erector pili muscles activating so they can try to keep you warm. Okay. There's a few different types of hair. First, there is vellus hair. That is the very thin body hair that you find maybe like on your face. On children, it is like very, very thin, very, very non-coarse hair. Okay. Terminal hair, you find that on your scalp and in the axillary and pubic areas, especially after puberty. Hair thinning and baldness, that can be due to a couple of different things. One is aging. Two, there's a genetic factor. So if your dad or uncle or grandpa or whatever started to go bald in their like mid-20s, good luck, soldier, you probably will too. Okay? And then aging, some people are just blessed and they just never go bald. It just goes gray, and that's cool too. Live your best life. Okay. There are sebaceous glands all over your body. So now we've moved on from hair. Now we're talking about some glands. Sebaceous glands. There's a couple of different types of sebaceous glands, but they're all over except for on your palms and soles. Which is what kind of skin? Thick skin. Which is where you will find what kind of, or what layer? Stratum lucidium. Stratum lucidium. Okay. These sebaceous glands secrete sebum, and that sebum is an oily substance, and that is what gives your skin its oil. So if you have relatively oily skin, you have active sebaceous glands. They are a simple alveolar gland. That will make sense when you are looking at the chapter 4 stuff that you're going to look at, right? Right, great. Okay. And they do holocrine secretion. There's two types of secretion, holocrine and merocrine secretion. Holocrine secretion will break the entire cell to do the secretion. Merocrine secretion just breaks open like a piece of it and then it covers itself back up. Okay. Most sebaceous glands are going to be associated with a hair follicle. They're pretty much one, like there will be a hair follicle, and the way that that sebaceous gland gets out is through that hair follicle most of the time. Sebum helps to collect dirt, soften, and lubricate your hair and skin. It's good for you. So don't get rid of all of the oil on your skin. It's good for you. Okay? Cool. Sweat glands, also known as sudoriferous, glands, you'll find those all over the body. Sudoriferous glands are smelly. That's why your sweat smells. There's a bunch of bacteria in there that eat the contents that come from these glands, and that is what produces body odor. Okay? Sweat is just super filtered blood. Okay? Contains some metabolic waste, urea, we talked about that a little bit, ammonia, and uric acid. You will see all of these wastes in urine as well. Okay. Two types of sweat glands, eccrine and apocrine. Eccrine glands produce true sweat. Apocrine glands produce a special sweat. And that special sweat is a pheromone. Pheromone sweat. Okay. Ceruminous glands make earwax, and mammary glands, once prompted, make milk. And those ceruminous and mammary glands, they are just modified apocrine glands. I'm going to stop here. We will. Okay, so this is getting into a little bit of disorders and things that can happen with the integumentary system. The first thing we'll talk about is burns. Burns are classified by their severity. Okay, a first-degree burn is going to just hit the upper epidermis. Not going to go too far into the skin. Probably a lot of the stratum corneal layer, the stratum granulosum might be a little bit damaged as well. Okay. A second degree burn. That's going to hit some of the upper dermis. You might get some blistering, and the skin will heal, but you will have a little bit of scarring. Okay. Getting into that upper dermis, you're getting into some of that blood supply innervation, so it will be a little bit more of a painful burn. Okay. A third degree burn. These ones are the bad ones. A third degree burn is going to get the entire thickness of the skin. Okay. So that's going to go all the way through the epidermis, all the way through the dermis, might even get a little bit into the hypodermis. Okay. And that burn area is going to look either white because there is no more blood supply, red due to irritation and inflammation, or blackened from the straight up burn. When we're talking about burns, especially in healthcare, we use the rule of nines to estimate the extent of the burns. So if one of your arms is burned, it's about 4.5%. The other one, same 4.5%. After a certain amount of percentage, there is a what we call survival likelihood. If over I think it's 50 to 65% of your body is burned, your survival rate drops by about half. Okay, so you can see on these fingers here, just the first degree burn, some redness, a little bit of swelling. In the second degree burn, you get some blisters. In the fourth degree burn, we have burned straight through all of the epidermis, and we are epidermis and dermis, and we are just doing what we can. Okay. Other things that can go wrong with your skin cancer, basal cell carcinoma. That's going to start in the stratum basale. That is cancer of the cells that are in that layer. Pretty common, not super malignant, doesn't tend to spread very, very much if caught early. Okay. Squamous cell carcinoma, That arises from the keratinocytes of the stratum spinosum, so that spiny layer. They can also do some division that gets messy, and that can form a cancerous cell. All cancer is excess cell division, uncontrolled excess cell division. Okay. And then melanoma. Melanoma is a cancer of the melanocytes, and it is a very dangerous type of skin cancer. Things that you look for with melanoma are the A, B, C, Ds, asymmetry. That's not how you spell asymmetry. You make sure that the borders are clear. I don't remember what C is, and I don't remember what D is, but there are the ABCDs that we look for melanoma to see if any like moles or anything like that are dangerous looking. So that's that basal cell carcinoma, squamous cell carcinoma, and melanoma. And generally, you wouldn't be able to tell which one is which without doing testing, histology testing, without a lot of experience. Except for the melanoma, because the melanoma will usually have a color to it. Throughout your life, your skin does different things. The epidermis develops from the ectoderm. The dermis and hypodermis form from the mesoderm. And then the melanocytes will form from the neural crest cells. We talked about that a little bit in embryology. Okay. As a fetus, your skin is pretty well formed after month 4. And in month 5 and 6, that fetus is covered in little lanugo, which is those kind of little tiny downy baby hairs. So when they're born and they look kind of like fuzzy, fatty thing kind of guys, that's that lanugo. Okay. And then the fetal sebaceous glands produce this vernix, and this vernix is that kind of like waxy cheese textured kind of thing that you see on newborns. And then as you get older, middle to old age, your skin will thin, it will become less elastic, and it will start to show some of the effects of the environmental damage. So if you did a lot of work in the sun, you will start to see more wrinkles, you will start to see maybe like sunspots or age spots, stuff like that. Okay? And then inflammation becomes a lot more common. So bumps, bruises, they tend to show up a lot more. That's why, like with old people, when you're trying to take their blood, you don't want to stick them too many times because their blood vessels, their skin will just look rough afterwards due to just the aged skin. Okay, and that wraps up the integumentary system.